Welcome to this July 1996 edition of Thammasat News Nightly. We are your hosts, Ben Tillis,
Barboros, Ozturk,
and Gabe Rueda. For our first story tonight, we will follow up on the crab heist that occurred last week in Florida. It has been confirmed that two seafood aficionados got away with stealing over $270,000 worth of frozen crab, totaling almost 10 tons of crustacean. With the help of their friend, who was an employee for the seafood plant, they lifted the frozen crab using a forklift in a semi-truck. Still, no word about the whereabouts of this crab.
Oh, what is this? I'm sorry to interrupt your important story, Gabe, but we have some breaking news. It seems that just now the first weather deal just took place between Aquila Energy and Consolidated Edison Co. However, I'm sure our viewers are not too familiar with the weather derivative, so we hand it to Gabe to go in a bit of details.
Thank you, Barbs. Yes, I am very educated in weather and its effects on businesses, so I would like to share my knowledge with you, Barbs, and the rest of our curious viewers. The weather affects our everyday lives. What to wear, the road conditions, but more than that, businesses highly rely on the temperature, the heat, rainfall, wind, etc. The easy example is a farmer. Obviously, farmers' crops rely on rainfall, but there are other examples too. Landscapers, ski resorts, and airlines, among many other companies, are affected by the weather. It is estimated that 20% of the U.S. economy is directly affected by the weather, and by next year, 1988, it is predicted $1 trillion of the U.S. economy will be weather sensitive. Customers can be affected by the weather. People may go out to eat less if there is no snow on the roads. Perhaps more inflatable toys for the pool will be purchased when the sun is out. Back to the farming, products depend on the weather. Some fruits and vegetables will become scarcer and more expensive. But the main impact the weather has on is the oil usage. When it is cold, oil usage increases, which raises the demand and the price. The opposite occurs when it is warm out. Lastly, bad weather can simply have a physical toll on a business. Flooding, tornadoes, and hail can be very destructive to factories and stores.
So you may be saying to yourself, well, what's insurance? Well, that's what insurance companies are for, right? That's what I was wondering. So why do we need weather derivatives if we already have insurance policies to protect us from all of these risks? Well, the reason is that insurance companies only protect against catastrophic damage and natural disasters. They do not deal with the reduced or increased demand or other effects as a result of weather. It is impossible to prevent the effects weather has on us, which is why weather derivatives were created. Just a few years ago, in the beginning of the 90s, people began quantifying and indexing weather in terms of temperature averages. They set dollar amounts to each value and were thus able to trade the weather.
Thank you for clearing that up, Ben. You really are finance-wise. So we are hearing reports now that it is predicted by 1999 that Chicago Mercantile Exchange, or the CME, will introduce weather futures and options on futures. You see, over-the-counter weather derivatives will be privately negotiated between two parties, but CME weather futures and options on futures will be standardized and traded publicly on an open market with continuous negotiation and price transparency. Why don't we hand it back to Gabe?
So let's get our hands dirty and really delve into what a weather derivative is. Weather contracts in the winter are tied to what is called the heating degree day, or HDD. This represents the days on which energy is used for heating. In the summer, we use cooling degree day, or CDD, which is days on which energy is used for the air conditioning. Both HDD and CDD are calculated based on how much the average temperature deviates from 65 degrees Fahrenheit, not Celsius.
But Gabe, how do you truly measure and value the weather and the HDDs and CDDs?
Of course,
Yes.
an HDD equals the number of degrees the day's average temperature is lower than 65. For example, if the average temperature is 40 for the day, HDD for that day would be 25. If the temperature is 65 or higher, the value of the HDD is 0. Because there is no need for heating on a day warmer than 65, CDDs work very similarly, just the other way around. If the average temperature is above 65, the value is how many degrees over 65 it is. As you can see, average temperature minus 65. If the temperature is lower than that, the value is 0, as there was no need for cooling. To get the total HDD value, or CDD value, you simply get the sum of all its values. If in November, let's say there are 10 HDDs, you add up the value of those 10 HDDs. 1, 8, 5, 4, 12, 3, 4, 3, 5, 8, 2. This adds up to 72 degrees. You then multiply the HDD or CDD value of 72, multiply that by $20 to get the true value. Which adds up to $14.40. In Europe, weather futures in the winter use HDD, with the average temperature baselined at 18 degrees Celsius. But in the summer, Europe uses cumulative average instead of CDD.
Now, the main use of weather derivatives is hedging and protection from risk. Weather futures are a very good way for energy companies to hedge their earnings. And here's a simple example of how. Let's say an energy company sells the right to someone to buy a weather index based on HDDs. So the more HDD days there are and the more extreme they are in coldness, the more expensive the index will be. And the energy company will lose money by selling the index at lower price agreed on in the future contract. Now at the same time, the energy company will make money because more energy will be used during the month. Either way, if there are more or less HDDs or CDDs, an energy company can hedge its earnings with weather futures. Farmers can use weather derivatives to hedge against poor harvests caused by falling rains during the growing period, excessive rain during harvesting, high winds in case of plantations, or temperature variabilities in case of greenhouse crops. Theme parks may want to insure against rainy weekends during peak summer seasons. A sports event managing company may wish to hedge the loss by entering into a weather derivative contract because if it rains the day of the sporting event, fewer tickets will be sold. Besides temperature, the underlying asset of weather derivatives can be rain, wind, humidity, snow, and many others. By 2015, weather derivatives will apply in select cities, 25 cities in the US, 11 cities in Europe, 6 in Canada, 3 in Australia, and 3 in Japan. Now we move to Ben to teach us about pricing models for weather derivatives.
There is no standard method of valuing weather derivatives. This is because the underlying asset of the derivatives, weather, is not truly tradable, which breaks many rules of a formula such as Black-Scholes that we use to price equity options and derivatives. One way to price these derivatives is the simple option pricing model, which is constructed by using the probability distribution for an historical data set of CDDs or HDDs and integrating the product of the distribution with the payoff of the option. The expected payoff of a CDD is determined by the integral of the product of the probability distribution of CDDs, the payoff of the option in CDD units, and the differential of CDD. So when we write it out, it looks like it equals M, which is the number of dollars specified in the contract per CDD, multiplied by the integral from CDD equals 0 to infinity of the probability distribution of CDDs multiplied by the payoff of the option in units of CDD, and then we also have the derivative itself.
The pricing model is the Gaussian pricing model. It is not perfect, but it is sufficient enough to be used by many investors. So you must know the average and standard deviation of CDDs and HDDs in a city for this model to work. The price, according to this model, depends on the standard deviation of distribution, the distance of the strike from the mean value, and the number of dollars per degree day specified in the contract. Next, we must find a value that depends on how many standard deviation the strike is from the mean, using this relationship. Here, y equals minus 0.03 x cubed plus 0.22 x squared minus 0.5 x plus 0.4, which can be visualized by this graph. The option value ends up being equal to the product of the specified dollar amount per degree day, the value we get from the relationship we just discussed, and the standard deviation of the degree days. Let's say we have a CDD call over a period for which the standard deviation of CDDs is 100 CDDs with a mean value of 1000 CDDs, and we define the strike for the option to be at 1080 with a specification of $5,000 per degree day. The strike is 1.8 standard deviations out from the mean. Using the equation discussed earlier, let's we determine that the value on the vertical axis corresponds to 0.125. The expected value of the option then is 5,000. The specified dollar amount per degree dash times 0.125. The number we just computed times 100, the standard deviation of the CDDs, which equals $62,500. Although it is a bit confusing, the math of the Gaussian model is not too complex and does a good job pricing options accurately. The most difficult aspect, though, is finding the mean and standard deviations of CDDs and HDDs. We will allow.
Thank you, Barbs. So like Barb said, it is difficult to know how to measure these temperature values. Should we use the last 5 years? The last 20? Weather drastically changes over time. The National Center for Environmental Protection proves that the previous 10 years is a better timescale than 30 years due to urbanization. The cities have become warmer because of the dense population and pollution. So 10 years is a common standard. Perhaps over time, longer periods will begin being used. Ben, we're getting a lot of calls from our viewers asking what basis risk is in weather derivatives. Care to explain?
Sure, Gabe. Basis risk is the risk due to options being written in a different location than the area which the user wants to cover. The basis between cities is the difference in CDDs or HDDs between cities. The basis can even be traded, so that a contract will be written on the difference between CDDs or HDDs between, say, Atlanta and Las Vegas. This can be very risky, as often there is strong correlation of temperature between two cities, but it is not uncommon for this to completely change especially for just a few months' time. Overall, there are many challenges to weather options. There are simple ways of pricing them and complicated ways, which adds to the difficulty. These derivatives can be useful to managers who understand their own risk and the risk of buying and selling weather derivatives. It is important potential participants in this weather market become well educated with resources provided by the National Weather Service, the Climate Prediction Center, and the Climate Diagnostic Center. Now, before we end our show, we have some viewers who are very curious and have some questions for us. Let's hand it to them.
Hi everyone from Thammasat late night news show. I'm a farmer from Canada, and because of your show now I can more edge my risk and predict how I'm gonna farm my crops in the future thanks to your show and what I've learned. And I'm gonna probably invest in the stock market and become a broker on Wall Street, maybe because of the inspiration you gave me through your show and all this financial knowledge that is so interesting to me. And I wanted to thank you guys for all for what I learned, basically. And I've also had questions for you about your. I heard you guys are in Thailand right now, and I wonder what is your favorite Thai food.
Gabe, why don't you go first?
My favorite is kadai my sok. It's really good.
It's good.
Yeah, tasty.
Barbs?
How about you, Barb?
I like seafood yam.
Ooh.
Yeah, that's awesome.
I like Gapao Mu Kai Dao. Pet Mak. And I'm Ben.
I'm Barbs.
And I'm Gabe.
And I'm Simon.
Oh yeah, and we'll see you tomorrow, Bangkok. Woohoo!
Kapung Makap.